Today, we're going to peel back the curtain on a tool that millions, and I mean millions, of developers use every single day, TypeScript. And we're going to do it by looking at a fascinating academic paper that reveals a core design secret that might just surprise you. It all starts with a paradox.
So get this. TypeScript was created specifically to add a layer of safety to JavaScript, right? To catch all those pesky errors before they cause chaos. So why on earth did its designers make a conscious, deliberate decision not to make its type system perfectly safe? Why build in what academics call unsoundness?
Well, to really get it, we have to rewind a little bit and look at the problem TypeScript was trying to solve. Back in the day, writing and maintaining huge applications in JavaScript, we're talking projects with hundreds of thousands of lines of code, was frankly a nightmare. With no static types, simple typos could go unnoticed for ages, and trying to refactor your code, it was like walking through a minefield, blindfold.
And this is where TypeScript's solution was just so brilliant. They built a rich, static type system right on top of JavaScript, and suddenly developers could catch a huge class of errors before their code even ran. This also powered incredible new tools that felt like absolute magic at the time, things like intelligent auto-completion and truly safe refactoring.
Now, a key ingredient in TypeScript's secret sauce is its use of structural typing, which is just a perfect fit for the JavaScript world. See, instead of caring if an object was made from a specific person class, TypeScript only cares about its shape. Does it have a name property? Does it have an age property? If it walks like a duck and quacks like a duck, TypeScript is happy to call it a duck. It's all about what an object can do, not what it's officially called.
And then they introduced this other concept, gradual typing, mostly through this special any type. And you guys, this was a total game changer. It meant you didn't have to throw out your entire existing JavaScript project and start from scratch. You could ease into it. You could add types gradually, file by file, function by function. It made the transition from the Wild West of dynamic JavaScript to the safer world of TypeScript incredibly smooth.
Okay, so this brings us right to the heart of the matter, the big trade-off. To get developers to actually adopt TypeScript and to make it work with the millions and millions of lines of existing JavaScript code and libraries out there, the designers had to make a choice. On the one hand, you have theoretical perfection, a sound system that guarantees zero runtime type errors. But that perfection comes at a cost. It would reject a lot of common, totally valid JavaScript patterns that developers used every day. On the other hand, you have practical usability.
And here's the crucial point. This unsoundness wasn't a mistake, it wasn't an accident. As the paper's author so perfectly put it, these weren't blunders, they were thoughtful compromises. TypeScript intentionally bends its own rules in very specific, calculated ways, all in the service of supporting how JavaScript developers actually work in the real world.
So what do these compromises actually look like? Well, you can think of them as these unsafe bridges connecting the strict world of TypeScript to the dynamic world of JavaScript. The any type is the biggest bridge, of course. It's a total escape hatch from type checking. Then you've got downcasts, which is basically you telling the compiler, hey, trust me on this one, I know this is a circle, without any checks to back you up. And finally, there's this more technical thing called covariance, which basically allows for more flexible function types that just so happen to match very common patterns, especially in popular APIs, even if they are technically unsafe. It was vital for making things just work.
The paper's authors have this really brilliant way of explaining this. They ask you to imagine TypeScript not as one system, but two. First, at the very center, there's a perfectly safe, mathematically sound core they call SafeFTS. Think of it as the ideal version. But then, layered on top of that is ProdFTS. That's the full-fat production TypeScript we all use, complete with all those pragmatic, unsafe rules that make it so incredibly useful in the real world.
So, let's tie this all together. What's the big takeaway from all this? It's that TypeScript's unsoundness is actually a feature, not a bug. It was a deliberate choice to put developer experience and compatibility with the huge JavaScript ecosystem above theoretical purity. The goal was never to build an impenetrable fortress. The goal was to build an incredibly useful tool that prevents the vast, vast majority of common bugs while still being flexible and easy for people to pick up and use.
And that leads us with a really interesting thought to chew on. In this world of messy, imperfect, real-world code that we all live in, is this idea of thoughtful unsoundness actually the best path forward? Maybe the future of language design isn't about chasing this impossible dream of absolute perfection, but about building smart, pragmatic tools that understand and help us manage the complexity we already have.